Hello, everyone. Today we are going to talking about Google Anthos for multi-cloud high availability. And in the previous, Google just talked about Google Anthos in a high level. So we are going to use a live case study to talk about how does Anthos can help a multi-cloud environment for high availability. And my name is Jonathan Zhuo. I'm a Google Cloud Senior Practice Lead at Deloitte with over 26 years of industry experience, a hands-on Google Cloud Enterprise Architect, and specialized in Anthos hybrid multi-cloud solution. Deloitte is a Google Cloud Platinum partner, and inside Deloitte, I and some of my peers with a managing director run Anthos practice. We have trained many teams to serve different accounts' need. We are constantly doing joint solutions with Google, and we are leading Anthos workstream for many companies. And also, I partner with AJ. He is going to talk with us on the multi-cloud industry trend. AJ, how about you give a brief introduction?
Yeah, absolutely, Jonathan. Thank you so much. Jonathan, do you want to move to that slide?
Sure.
All right. Good morning, good afternoon, all. My name is Ajay Shenoy, and I'm a manager in Deloitte's AI and data practice. I'm based out of Minneapolis. I have about 17 years of experience in delivering data and analytics programs. I primarily focus on healthcare industry and help them accelerate some of their, the future journeys, especially around digital transformations. I think one thing we realize as part of these accelerations, right? The primary focus or cloud is becoming more and more essential, a core fundamental element, and organizations are moving swiftly, from moving to the cloud. Yes, absolutely. But they're also moving on a hybrid multi-cloud model. And I'm going to talk a little more about, I'm going to give an industry perspective on this and how we are seeing things happening in the market. Can we go to the next slide, please?
Mm-hmm.
One after that. All right. Thanks, Jonathan. So let me first talk about, the benefits of a multi-cloud. I think this is going to be a little more generic, but here's our perspective. As we're seeing organizations are looking to modernize their applications, we're seeing that there is a growing need for access to the best of breed abilities, capabilities from multiple cloud vendors. Multi-cloud is helping or allowing organizations to avoid these vendor lock-ins and be vendor agnostic. Even though a single cloud provider, it offers high resilience, a multi-cloud environment offers companies with a lot more better improved disaster recovery and even higher resilient capabilities. Multi-cloud also offers geographical coverage, and it allows organizations with greater data processing scalability to improve their speed to market. Now, obviously, benefits always are coupled with challenges, and we see them as opportunities in the world of implementing multi-cloud. So let me take you through those 4 items at the bottom. The first one, hybrid and multi-cloud discussions are on the minds of every leading CTO, CIO, due to the risk aversions from lock-ins and the best of breed capabilities that they need. And it's becoming a reality more and more in larger enterprises. But there are several questions that stem out of this, like, for example, how does one modernize in this hybrid environment? How are they going to use the different processes? Are they going to have different best practices? Are the operational procedures going to be the same or different from each of these cloud environments? Or lastly, do we need different skill sets in order to manage this cloud and the on-prem environment? Or is it getting this overly complex at this point in time? So those are the first kind of challenges that the organizations are dealing with right now. But secondly, there is a rise of platforms. We can see that many enterprises are now looking to modernize their applications with regulations in mind, with compliance in mind. And there is hesitation in moving towards a more, moving their more critical workloads to the cloud. Their more critical day-to-day operational stuff over to the cloud, which becomes their core, the heart of their work. Now, does it make sense to have this workload move to the cloud or let it reside on the on-prem data center because it's a legacy system. They're also looking for, can they run these workloads not only in cloud, but also on the on-prem environment at the same time? So that poses a different kind of challenge now, which is with respect to automation. From an automation standpoint, organizations are thinking, how can I implement an automation framework so that I can deploy these applications, the critical applications, on-prem and on cloud at the same time, or multi-cloud at the same time, and how can I have this so that there is a seamless experience, regardless of where I am deploying? Should I be building a reproducible environment that can be deployed both in cloud and on-prem? So that poses an automation challenge. But finally, the most important one, I think, is from a governance and continuous compliance standpoint. Organizations are thinking, how can I set up an enterprise level policy controller? How can I set up the compliance guardrails, as well as implement the enterprise level governance at scale across hybrid cloud and multi-cloud environments? So with these challenges, I also see opportunities and solutions through Anthos that we can actually achieve the solutions. So I'm going to hand over now back to Jonathan, who's going to be talking through and taking us through a live case study. Over to you, Jonathan.
Thank you, AJ. So in this case study, I'm going to, first of all, show you what is the high-level requirements the client is asking. And then I will talk about why Anthos can help you in multi-cloud environment. Then I pitch in through using two different approach. How are we going to implement high availability in multi-cloud environment? And at the end, I'm going to do a demo to show you. So if you look at the high-level business requirement, the client wants the commerce site never goes down and feels fast anywhere in the country with low latency, and build a reproducible environment that can be deployed in Google Cloud or any other cloud, and use a single pane of glass to manage workloads in multi-cloud environment. And on the technical side, they want to implement in using microservice-based architecture, and the service runs in Kubernetes clusters in the cloud, and want to have a 99% of the uptime, and resilient to multi-regional disasters and can fail over second public cloud. At the meantime, want to reduce request latency for clients across the country, and without any application code changes can be deployed into multi-cloud environment. And based on these requirements, we come out with a high-level solution. First, leverage Anthos multi-cloud capability and to install Anthos clusters on other public cloud. So applications can be deployed to GKE, runs on GCP environment, or Anthos runs on other public cloud without code change. And also through a single pane of glass, then operators can manage clusters on multi-cloud environment and use consistent operation procedures. In terms of high availability, there's a two different approach we propose to the customer. One is that leverage Anthos multi-cluster Ingress. It's also called MCI, and a third-party vendor's product called Cloudflare for multi-cloud high availability. And the second approach is that leveraging hybrid mesh for multi-cloud high availability. I'm going to walk you through in detail on each approach. But before we do that, first of all, let me introduce you why Anthos can help multi-cloud management. In this picture, you can see I'm not only able to manage GKE clusters runs on Google Cloud, but also I can manage Anthos clusters runs on AWS or Azure, or even I can attach any CNCF compliant Kubernetes, let's say AKS or EKS. And it's not a secret among 3 public cloud providers. Google was the last one decided to go to public cloud in the market. So Google is heavily focusing on multi-cloud solution. And this picture, you can see that is the underlying Anthos multi-cloud architecture. And for Anthos, on other public cloud like AWS or Azure, and it uses multi-cloud API, Anthos multi-cloud API, to directly administrate the life cycle of VMs, either in AWS or Azure, and load Google Kubernetes on top of that. And you can control the entire lifecycle management remotely through Google. So what is Anthos cluster? Anthos cluster really actually is a GKE, actually runs on using AWS or Azure as an as a IaaS and installed on that. And certainly it also can attach, as I said, CNCF compliant Kubernetes clusters like EKS or AKS. But for this particular one, we are talking about just Anthos clusters, which is AKS, which is GKE runs on AWS or Azure. And you can control you can control the entire lifecycle management remotely through Google, and supporting either Terraform or Google Cloud SDK to facilitate the setup or tear down the cluster. And also through Connect Gateway to log into Anthos clusters remotely. Next slide is that if your workload use, let's say, Anthos Service Mesh, you do not need to do anything. And this picture actually presents you the observability you can get. For any service, you will see how many requests per second, what's the error rate, what's the latency, and even a topology view. For example, which services invokes which service, even at which version. In addition to that, you can also set service level objective as promised. Let's say I promise you 95% of the time, my service will have less than 350 milliseconds latency. And I will alert when this promise is broken. So that is a huge benefit to the operators. So in short, we talked about you can leverage on Anthos as a single pane of glass to manage your Kubernetes clusters workloads, whether they run on as a public cloud or on GCP environment or even in on-premise environment. And also, because Anthos clusters really is like GKE clusters, so you do not need to change your custom code. You can deploy into these environments without much challenges at all. From operator's perspective, you can have a very nice observability and also to trigger alerts in case to ensure your service level agreement. So that's the benefit of the Anthos. The next piece, we are going to zoom in to the high availability piece. The first scenario, we actually was help the client and proposed and implemented this solution using third-party vendors product called Cloudflare, and in conjunction with Anthos multi-cluster Ingress to achieve multi-cloud high availability. So what is a multi-cluster Ingress? Let me use this diagram to show you a little bit. In this picture, you can see I have multiple clusters, and they are in multiple regions. And I go through health check. And once I detect that one of the cluster is not healthy, the traffic will be auto failed over to the other one. And from application perspective, you will get a single consistent virtual IP for your application. See the IP address, they are the same. And it's geo-proximate based routing. So let's say a user is using this application in West Coast. It will be routed to the nearest cluster, which is on West Coast. If a user lives in Europe, and then the traffic will be routed to the Europe cluster. And if the Kubernetes cluster is down, for example, during the scheduled maintenance, all Kubernetes services running on that cluster are also down, which is not ideal. So running multiple clusters make a cluster lifecycle management much easier because you can bring clusters down for the maintenance or upgrades while other clusters still serving the traffic. It is extremely valuable for multi-tenant scenario. And if we look at the right side of the picture, that will zoom in even further into how a little bit more technical perspective. You can see here I have GK US, GK EU, GK Asia. These are the clusters, and if they register into the fleet, they will be called member clusters. And the fleet is nothing but latitude to logically group GK clusters, making administration of infrastructure easier. And if you look at this one, this is also called a multi-cluster ingress controller or MCI controller. That is a globally distributed control plane that runs as a service outside of your cluster. And this allows the lifecycle and operation of the controller to be independent of your GK clusters. And also a multi-cluster service or MCS is another concept. It's the customer resources used by MCI to represent sharing services across clusters. And if you look at this one called a configure cluster. And the configure cluster is a GKE cluster. And it can be an independent cluster or can be deployed into one of these clusters. And where the MCI and the MCS resource are deployed. And the Ingress controller watches the config cluster and reconcile the load balancing infrastructure. For example, I say load balancing between these two clusters, US and EU, and not involve Asia. It will do so. So let's further look at it. Since the client is not only just interested in high availability in GCP environment, but also want to expand it to multi-cloud environment. So there is a proposed solution comes out. The picture is that we use third-party vendors product called Cloudflare. And the Cloudflare is DNS-based load balancer with DDoS mitigation and web application firewall. And it can, you primarily route the traffic to Google Cloud, and let's say, and then fail over to the other public cloud. Let's say a normal scenario is that through global load balancer, it comes in, and first of all, based on your geolocation of the user, and maybe initially send the traffic to GKE West, and since the user is based in West Coast. And only during the failover scenario, it will be routed into the GK East. And if both clusters are not functioning or not responding, does not take in the traffic, at that time, Cloudflare will route the traffic into another public cloud. And in that cloud, you will have Anthos clusters, which is installed exactly the same application, and all the infrastructure are pretty much exactly the same compared with on the Google Cloud. And the reason we selected this approach is that Anthos hybrid gateway is still on the roadmap, and hybrid Anthos service mesh is still in preview, and the Cloudflare has more than 300 endpoints globally. That also supports DDoS mitigation and web application firewall. So how you implement it? It's pretty simple. In the Cloudflare, you can just create original pools. Your GKE pool is your primary pool, and then other public cloud is your secondary pool. So GK is the primary pool, and the other cloud is the secondary pool to make your traffic pretty much as based on geolocation and route into your Google Cloud environment and fail over to the other Google Cloud environment if needed. And if both of them are not working, and then fail over to the another public cloud environment. So that sounds like it should be pretty, I think it should be pretty straightforward, this approach. Another approach is a very different one. It's called hybrid mesh for multi-cloud environment. Oh, by the way, this one later on I will do a demo once we finish talking about this presentation. Hybrid mesh certainly is a different approach. And first of all, let me explain to you what is a hybrid mesh. Is anybody have any questions so far?
Yeah, can you hear me, Jonathan?
Yes, I can hear you.
Okay, so can you go back to the previous page about the Cloudflare? I want to understand a little bit more on what did drive you to make a decision to introduce a Cloudflare as a third party? Is there any like a Google native product that have similar functionality? And I see there is a like a DDoS seems like it enforces security. Is that the reason, or?
It's a perfect question. Must be from YT, right? Yeah. So as I mentioned about before, there is a way, and Google actually put into the roadmap. It's called Anthos hybrid gateway. Once it's implemented, this piece is no longer needed. It will direct the traffic between Google Cloud and the other public cloud. That's one way. Second is that if this client workload is using mesh, and also, well, actually this client workload does not using service mesh at all. So that meshes idea will not work. But if they do use Anthos service mesh, we have another approach to do that. So that hopefully answered your question. In general, they do have a product on the roadmap called Anthos hybrid gateway. And before that one comes out, we use the Cloudflare.
Okay.
Yeah. Cool. And the Cloudflare has more than 300 endpoints worldwide, so it's widely available. So hybrid mesh, that's a different approach. This concept is a little bit complicated. If you look at it here, I have what is hybrid mesh? I span Google Cloud and other public cloud, or sometimes let's put a on-premise environment on the side. Let's just using these two. So I have two clusters. One cluster runs on GCP environment, another Anthos cluster runs on other public cloud. And I use one single mesh, link them together. And each cluster, they use their primary control plane. And they reside in two different clouds, so they are using multiple networks. Each of them use their one is on Google Cloud network, and is on as a public cloud network. With clusters on separate networks, you must install east-west gateway, since traffic cannot be routed from parts in one network to parts in another. And since the clusters are on separate network, you need to expose all services on the east-west gateway in both clusters behind this east-west gateway. Service behind the gateways can only be accessed by service with a trusted mutual TLS, certificate, and workload, the workload identity, just as if they were on the same network. And finally, you need to run ASM CLI to create a mesh to enable endpoint discovery. If you have only one cluster, that's very simple. You just install your cluster and then install service mesh and then deploy your application. Your service will be exposed. But for multi-cluster environment, how can you make it enable your endpoint discovery? You need to go through these steps. First of all, you will generate east-west gateway, and then expose your service behind these gateways. And the third one, run ASM CLI, create mesh, to enable endpoint discovery. Once you enable it, it becomes, these services becomes like a distributed service. I will describe to you what is distributed service in that. A distributed service is a Kubernetes service that acts as a single logical service. For example, I have a front-end service on both sides. One cluster here, another cluster here, they call it front-end service. And the distributed service is a single logical service. So, but sometimes it's routed traffic into here, and sometimes the routed traffic to over there. It's a logical service. And the distributed services are more resilient because they run on multiple Kubernetes clusters in the same namespace. And a distributed services remains up even if one or more Kubernetes clusters are down, as long as the healthy clusters are able to serve the desired load. And in order to create a distributed service, Anthos service mesh functionality is used to link services running on multiple clusters together to act as a single logical service. Later on, when I do a demo, you will see these things more clearly in the on the screen. And the MCI, as we talked about before, create a load balancer for the application using cloud load balancing, which is here, global load balancer, and also creates and manages the network endpoint group. It's not reflected in this diagram. And this load balancer has the Istio Ingress gateway. If you see here, Ingress gateway here and here on both clusters. And this is a unique from service mesh. And the network endpoint groups dynamically track the service endpoints of these two Istio Ingress gateway service to ensure the load balancer has the healthy backend. If it is not healthy, the traffic will be routed into the other one. And the service runs in pods that use workload identity, and which provides each pod with a unique identity. And workload identity lets Kubernetes service account, which is called KSA, act as a Google service account, which is also called GSA, by creating a secure mapping between the KSA and the GSA. We constantly heard about workload identity, that is this concept. And the pods that runs as the KSA automatically authenticated as the GSA when they access the Google Cloud APIs, because workload identity allows IAM, Identity Access Manager, to trust Kubernetes service account credentials. So how does traffic work if you piece everything together? Actually, this diagram needed to add two pieces. One is the east-west gateway here and east-west gateway here, so they can communicate with public third part, another, let's say AWS cloud, Anthos cluster. And AWS cloud also have an Anthos cluster, also has an east-west gateway here. So they will communicate to each other. So the traffic comes in like a load balancer comes in, and then it will have a network endpoint group monitoring ingress gateway here and there to see whether it's healthy or not. And if it is healthy, then the traffic will continue, stay here. And then since it's a logical service, let's say front-end service needed to invoke transaction history service. At that time, transaction history services resides on both clusters and even in AWS clusters. At that time, it will do round robin between each other. So sometimes invoke transaction history service here, sometimes it's another time here, or even there. And certainly that is to give you very high availability, but that also introduce a problem. The problem is called when you cross region traffic can generate more latency, right? And across cloud, the traffic will give you even more latency. So how to address that? The locality-based routing, as you can see in this code snippet, in the destination rule, I set locality load balancing enable to true. And in normal scenario, the traffic stay in the same region. But it can fail over to the other region. That will give you the best performance and resiliency. So I hope you have got some picture regarding how are we able to using hybrid mesh and to cross cloud and form a logical service to round robin from each other to invoke the service deployed into each cluster and each cloud. And also using this locality-based routing to control the traffic normally stay in where you are, only during the failover go into the other region or other cloud. So in conclusion, today we talked about three things. One, use Anthos as a single pane of glass for multi-cloud management, and use Anthos clusters on AWS, Azure, or on-premise environment. Actually, not only on-premise environment, also on edge environment, without changing your application code. And two, that is a high availability approach, using multi-cluster ingress for multi-regional cluster high availability, auto failover, geo-proximate based routing to lower latency and makes cluster upgrade and cluster rebuild much easier. And in conjunction with Cloudflare to provide multi-cloud high availability. The second approach is using hybrid mesh approach, using Anthos service mesh hybrid mesh to create a distributed service on multiple cloud, multiple clusters to act as a single logical service and provide multi-cloud high availability. This piece currently is in preview, and next year, once it's in general available, I'm going to do another demo on that piece. Now, let's get into Q&A session to see anybody have any questions before we go jump into the demo. Let me know anyone have any questions.
Jonathan, this is YT again. So I do have many questions. I'm not sure we have enough time to cover. How much time we have?
How much time? 12, right now it's 12:05. The demo will take 10 minutes. Do you want to do, let's shoot 3 questions. How does that sound? YT. And then we do demo, and then we do answer your remaining questions.
Well, yeah, let's touch base. The first one, let's just do one question probably.
Okay.
I want to understand a little bit more about how you arrange the network, especially like the IP address range. So like in the use case, the corporate, they have on-prem like a network environment, right? Like have AWS, you have GKE. You want all of these. First of all, you want them routable, and each cluster they might have a non-routable IP address space to hold the service made visible internally. So, is there a policy how to make the arrangement, like what should be routable, what should be non-routable? Is there any suggestions on that phase? Because the more non-routable, the more efficient it would be, but it will add a lot of challenge. But if you make everything routable, you might run out of space really quick.
Right. So I fully understand where do you come from on this question. So in corporate world, certainly your IP address cannot collision with your IP address resides in your on-premise environment. Your IP address in your on-premise environment is not a public IP address. And you also want to have your Google Cloud environment or does not have this kind of overlapping with each other. And so that is, we used, I believe it's called how do we say that? We suddenly one actually I believe we used one is called Private Service Connect, and also is in each we call the network, we have a shared network, shared VPC. Shared VPC, that shared VPC, when you through interconnect with your on-premise environment, and the network address needed to be arranged on that perspective, and they are not collided with each other.
Yeah, but that only work for the Google Cloud, right? You have a multiple provider, you have AWS.
Yeah, your AWS cloud in that scenario, your AWS cloud is a public IP address, and you are actually runs your workload over there, and you do not directly interact with your on-premise environment in that scenario. Your Google Cloud does, is the primary cloud provider, and you do have an connect with on-premise environment, and your IP address is really assigned between each other, and your AWS cloud is different one.
Okay.
So that helpfully answered your question on this.
Well, yeah, partially. We might follow up on more deep dive on that. It seems that might not be a lot of kind of corporate policies.
Yes.
In this case, the AWS need to be in public. Well, that's not allowed, especially for banking, healthcare industry. We might want to deep dive on that.
Sure. Other questions, or you want to, or any other questions people have? All right, we can do this way. We can do this demo. This is the demo to demo multi-cluster ingress. What I'm going to show you is that I have two clusters. They are resides in two different regions. And also, I deployed the same application called Bank of Anthos in both into both clusters. Same namespace, same identical applications. And this application does use two databases. And we are going to using MCI, multi-cluster ingress, to route the traffic to the nearest clusters. And I will demonstrate that and prove it. Second is that I will create a failover scenario. Let's say your service is no longer healthy. How we will see the traffic will be routed into the other clusters. So that's the scope. Let me stop sharing this one and sharing the other screen I have. Let me know you can see it.
Yes.
Yeah.
Yeah, okay.
Jonathan, before we move forward on this, YT, are we good on time? Do we still have 10 minutes for us to go on this?
We should. We started late, right?
Yeah. Just want to make sure we have time.
Yeah.
Over here.
We started at 12:25 actually. So this demo is that you can see I have two Kubernetes clusters has been created. One is on US Central, another in Europe cluster. The reason I select US versus Europe because if I want to do a demo, I can go anywhere in US and then it will never send the traffic into Europe. So that's the purpose. Second is that this is my Cloud SQL and PostgreSQL in Google Cloud. And I installed two databases. One is created two databases. One is the account DB, another ledger DB. These are used by this Bank of Anthos application. Third one, I deployed this whole Bank of Anthos application into these two clusters. And you can see these services are duplicated because one resides in BOA1 and BOA2. And front-end service was exposed through global load balancer. And actually, if you click on that, you can see Bank of Anthos through each cluster. Next step, I not expose this front-end service. Instead, I created a front-end multi-cluster service. This is multi-cluster service. Let's zoom in what's behind this multi-cluster service. So behind the scenes, it have two backend and runs on US cluster and Europe clusters called frontend. Although I did not expose it directly, but their pods are still running. And you can see these are the pod. Each service has one pod running on over there. And also, let's look at our global load balancer. This load balancer has two network endpoint groups. What are these two network endpoint groups doing, and where do they reside? Not surprising, one resides in US Central Cluster, another in Europe Cluster. And they are monitoring the front-end service to check whether it's healthy or not. If it is not, then the global load balancer will know this cluster, let's say, US Central is no longer healthy. So it will route the traffic to the other cluster. And let's look at this is Bank of Anthos application. After I log in, I can see my transaction history. And this is my IP address ending with .255. And then if I check where am I, since I'm the user using this application in US, so well, no matter how many times I refresh, it always tells me I'm in US Central. US Central cluster is serving the traffic. It tells me that. And then I'm going to do something is that I'm using kubectl to scale down my deployment of frontend to set replica to 0. So replica is set to 0. You can see pod is changed to 0. That means my network endpoint group will detect my front-end service is no longer healthy. So, however, from my application perspective, everything runs just like normal, nothing changed. Reality is that the traffic has been routed into the Europe West. This is the proof. Now, let me do something. I scale back of my deployment of the front end to replica equals to 1. So everything backs to normal. Both clusters are healthy. The next thing is that how can I prove European users are really routed traffic to Europe clusters? Since I'm living in US, so how to prove it? What I did is that I create a Europe instance, which is a VM. And through this VM, I run a command or curl command and this URL and ask, where am I? Guess what? It tells me you are in European cluster. So this is the conclusion of our demo, multi-cluster ingress. And the next year, once a hybrid mesh becomes general available, I'm going to do a demo on the hybrid mesh. Stay tuned. All right. Any questions you guys have? If, or any questions in the, let me see, in the share window.
And you guys can always connect with us offline as well. We will share our email IDs for you guys to post any questions to us offline, and we can have offline discussions around these topics as well. We're happy to do that.
Thank you.
If no,
Thanks a lot. Those are very sophisticated patterns.
actually it's not. But if no further questions, we can conclude today's session and see you next time.
Thanks, everyone. Thank you.
Thanks.
Yep.
Thank you.